Israel is outpacing most countries when it comes to advances in technology. It's said there are more billionaires per capita here in Israel than any other country. One area where these advances are excelling is the treatment of cancer. I'm at the Baxter Hadassah Research Center, where I'm about to speak to Professor Polina Stupensky about a cancer treatment that may soon be available in the United States. Doctor, it's very nice to meet you. In 2 seconds, tell me what's so exciting about this therapy.
You know, it is something what we are able to do for our patients by ourselves. We are not dependent from Big Pharma. We can do it by ourselves. And we can develop it and change it, and to produce personalized therapy, because it is exactly the personalized therapy. We are taking the cells from the patients, we are modifying them, and we are giving them back.
Are you teaching the patient to cure himself?
In some way, yes. It is exactly what happened.
So this CAR-T, what is that?
So we are taking the part of antibody and putting this part within the T cells, our lymphocytes. So these are the T cells are the cells of immune system which are fighting against everything.
Okay, so let me stop right there. So the T cells, they're the army in our body that fight problems, right?
Yep.
So you take the army out of our body because it's sort of getting tired and exhausted, it's not doing a very good job, and you beef it up with more T cells. You do something to the T cells, and you give them directions about what they're supposed to do when they go back in.
Exactly.
And then you send the army back in to fight.
Exactly. It's exactly what we are doing. We are taking T cells, we are educating them, we are putting some genes which encoded this weapon against the cancer, and we are giving these cells with weapon to the body. So we decided to start and to expand this practice for our Israeli patients with specific type of cancer, because we started with something very practical, very focused, and
you say a specific type of cancer. So so this is not a therapy for all cancers.
It is platform. You can develop this platform for every type of cancer, but what we are doing now, we are working on one type of cancer, very specific. Next step, we are able to produce these CAR-T cells for another type of cancer, but this is a different project. But now we know how to do it because we have a platform.
I'm at ADVA Biotechnology here in Israel, and they've developed a new device to treat cancer. All right, let me ask you the flat-out question everyone wants to know. Can you cure cancer?
I can't cure cancer,
okay,
but I can definitely help other scientists bring their cures to patients.
Can cancer be cured?
Some of it, yes. So there are existing cures that are very, very complex, where you take T cells, so immune cells of the patient, train them to identify cancer, and send them back to do their work. And it works brilliantly.
Isn't that curing cancer?
That is curing cancer.
So you can cure cancer?
Well, the issue is it's very complicated.
All right, now this is your machine, right?
Yep.
What is this?
So this is basically a full factory. Okay, we have a refrigerator, we have an incubator with a kit in it that the cells grow in, with all the different sensors and connectors that you would need, and another chamber where all the waste goes out. So basically, we will put the materials that you need to grow cells in, we'll put the cells, press play, and let the device do all the...
All right, there.
So once they're in there, what we do is we activate them. So we try to agitate them for them to start to grow, because T cells normally walk around. If they don't find a enemy, they don't do anything. So you need to trigger their activation. Then you educate them to identify the target by adding a virus that has that target on it. And now you're teaching them to identify that target, grow like crazy. So from a few million that we took from the patient, we're going to have a few billion that are walking around looking for that specific target.
Now, you said that these are basically, you're getting your army, your T cells, and you don't want too many T cells because you don't want them to go into overdrive and basically have a coup and start eating your good cells.
Right.
All right. How do you determine that right amount?
So that's part of the clinical trials that are done to identify what is the right dosage that will maintain, that will do the job and not be too much.
So back to where we started, it does seem to me, I mean, forget the cost, forget the personalized medicine, forget the time and the sophistication of everybody. It is really a cure for cancer, can't you? I mean, in reality, I mean, nobody wants to use the word cure for cancer, but if you could, I mean, if you could handle all those things. And that's a big hurdle.
No,
but it is a cure for cancer.
But I'm not a physician, but there are physicians that call these types of therapies as a cure because there's patients that they had no other option. They were about to die, and 11 years till now, they're living cancer-free. So this really works.
It really works. Yeah, anyway, it's amazing. Anyway, well, thank you very much.
Thank you.
Thank you.